Hello and welcome back to this new video in the Learning to Program with Go series. And today we're going to be covering the third video in the Slices sub-series. Today we're going to be looking at the Slices package over here at package.go.dev/slices. And we're going to start off by using the clone function. So you can just do a Control F here, or just look down here in the list and you'll find clone. So if you click on that, it gives you a quick description and actually even an example. So I'm going to be a little redundant today and show you examples of all of these functions too, just to reiterate what they're doing. So we have this function clone, and here's its signature. And really what happens here, everything is a static function in this package we call slices.clone, and then we're going to give it some sort of slice to clone. And the description here reads, it returns a copy of the slice, and it's copied using assignment, and so it's a shallow clone, meaning that whatever cloned slice that we get back, we can modify it, and it's not going to modify the original slice that we cloned from. So the result may have additional unused capacity. And so it gives us an example, but I'll go ahead and provide one for us now. So let's switch over to VS Code. And here we have our main where we're importing the format just so we can print some stuff out, and then also the slices package. And I'm going to declare a slice called slice1, and it's going to be an int slice, and it's just going to hold one number for simplicity. Then we're going to have a slice2 called s2, and we're going to initialize it to this. So we're going to say slices. So we're calling the slices package, then call the clone function, and then pass in s1. That's all we have to do to clone it. So let's first print these out. So a format.printf with s1, then we're going to copy this and then pass in s2. So let's first confirm that these two slices are the same. So if I do a go run, we see that they both print out 1. But if I go down here and I say s2 at the very first index, it's going to be equal to -1. Let's save and run this again. We get that now S2 is independent of S1. S1 remained with having only 1 as its first element, and then S2 changed to having -1 as its first element. So that's the clone function. Next up, we have the concat function. And if you've worked with strings before, you would think that, oh, concatenating strings, we're just putting two strings together. And that's exactly what is going on with this function. We see that it actually takes in multiple slices. So we can pass in 1 slice, 2 slices, 3 slices, however many you want. It's a variable argument parameter. And so it returns a new slice concatenating the passed in slices. So let's jump over to VS Code and demonstrate this real quick. So here I have a slice, S1 with only 1 element in it, and then I have slice or S2, which is another slice holding 2, 3. So if I create another slice called S3, I can initialize it to slices.concat, and I can pass in S1, and that would work. Or I can also pass in S1 and S2, and that would also work. So let's go ahead and pass in S3 to prove that it actually concatenated them all. Let's go ahead and run this, and we see that now S3 is set to 1, 2, 3. Next, we have the contains function, and if you've ever worked with strings or lists or collections, there's always a contains function, and the function here in the slices package does the same stuff. It reports whether V is present within slice S. So again, you pass in the slice, then you pass in what you're looking for, and then you're going to get a bool returned to you saying true, yes it is in that slice, or false, it's not in the slice. Let's hop over to VS Code again. So here I have S1, which has 1 element in it, the number 1, and then S2 has 2, 3, and let's just print out slices.contains, and so we'll pass in S1. So we're going to look inside of S1 for a particular element. So if I look for 0 over in S1, it obviously does not exist. Let's actually comment out S2 and let's run this. So we'll see that false. It's 0 is not contained within S1. Now if we switch over to S2, we can go ahead and say is 0 in S2, but it's not. But we can go ahead and put in a 2 here. Can run, go run, and 2 is contained within S2. Now we have the delete function, which just removes elements from the slice and returns the modified slice. Again, remember you're still using the shared memory, so you'll need to clone it if you want an independent deleted slice. What it takes here as the first argument is the slice, then the start index to delete from, and then the exclusive end index to delete up to, and lastly returning that modified slice. It will panic if your exclusive index is greater than the length of S, or if the ij pair that you pass in is not a valid slice of S. And it is best to go ahead and delete everything at once rather than deleting single elements at a time. Let's go look at this in code. Here I have slice 1, which is 1, 2, 3, 4, 5. And if we just call slices.delete on S1, and we're going to just remove the very first element, let's run this, and we get 2, 3, 4, 5. So those values got moved up 1, and then it appends the 0 or just zeroes out one of the elements because it's just going to put it at the end, but we can still work with the 2, 3, 4, 5. Now, if you don't want that extra element remaining in the slice, what you can do is just reassign it. So we can say S1 is equal to slices.delete. Then we go run this again, and now that 0 is no longer at the end of the slice. Next, we have the index function. So it takes in the slice and then a value that we're looking for, the index of within the slice, and returns the integer index back to us. So just like I had said, if the value is not present in the slice, then we get a -1. Let's go back to the code. And here we have slice 1 again that we've been working with. So what we can do is call slices.index. Then we pass in the slice that we're going to look into, and we'll look for 1, for instance. If we save this, we can call go run, and we'll see that number 1 was found at 0. We can modify this to look for 2, rerun this, and we'll get that 2 was found at index 1. Now let's look for 100 in this slice. We rerun this and we get -1. It's not present in the slice. The insert function inserts elements, 1 or more, into a slice at a given index. So let's read through the description here. It inserts the values v, so var args just like the append function, into slice s, starting at index I, returning the modified slice, and it shifts up elements to make the room for it. So here we pass in the slice that we're going to insert into, the starting index, and then all the elements that we want, returning to us a slice. Let's go look at this in some code. As always, our S1 slice is here. Now let's go ahead and insert -1 and 0 into slice 1. So if I want to do that, we'll go ahead and say slice is equal to slices.insert, and we have to pass in S1 again. Then starting at element 0, so like I am prepending, I want to insert the elements -1 and then 0. Let's go ahead and save this, remove our previous call to the slices.index, instead put in S1, and let's run this. So now we have -1 and 0 were prepended to this slice. We can also insert somewhere in the middle, so I can change this initial index that we want to insert at maybe, let's go with 3. So this is index 0, 1, 2, 3, so it's going to insert right here. Let's go ahead and run this. So we get the -1 and 0 inserted right there, and then 4, 5 is put after it. Remember that we can also list out elements in a slice. So if I had slice S2 and it's equal to an int slice with the values of -1 and 0, instead of having to list these items out here manually, we could do S2 ... and that will do the same thing. So let's make sure that it's the same slice, and it is. And so that is the insert function. I've mentioned the equal function in a previous video, but we'll cover it here again. It's fairly simple. You pass in one slice and then another slice, and you see if they are equal. So reading the description, it determines if they are both equal. They must have the same length, and all elements within them must be equal. It'll short circuit for us if the lengths are different, and then if they are the same, then it'll start comparing by each index, comparing the elements. That's as simple as it gets. So let's go look at code. Over here we have S1, which has the elements 1 through 5, and then S2 with -1 and 0. So if we go ahead and print out slices.equal, passing in S1 and S2, saving, we'll see that they are not the same. But if we go ahead and say S2 is equal to slices.clone S1 and then save, let's run this again, and we get that it is true. Even though that they are two different copies of each other, that I cannot modify S1 and it'll affect S2, and I cannot modify S2 and it'll affect S1, they are still equal to one another. The repeat function takes in a slice and a count. So it will repeat the given slice, count amount of times, and return to us the modified slice. It will only panic if the count is negative, or if the length of the slice that we're passing in times the count is going to overflow in our program. Over in code, I have slice 1 with 1, 2, 3, 4, 5. Now let's go ahead and print out what slices.repeat will give to us. So if I say slices.repeat, and I'm going to give it S1, and I want to repeat twice, and we save this, we can run this, and we get 1, 2, 3, 4, 5, and then it repeats one more time after that. Just to see the panic, we can go ahead and put in a -2 and save. We run this, we get the big panic running through here. The min function will go ahead and find the minimum number or value of the slice over in X. So just given the slice, it will return to us that minimum value. Over in code, I will go ahead and demonstrate both min and max. It's fairly straightforward. So if we have slices.min of S1, it'll give us 1. And then let's copy this print statement and also do max real quick. So max, let's save this and run, and we get that the minimum was 1 and the maximum was 5. That's fairly straightforward, but it is a handy function. Lastly, we have the sort function, and just as it says, it sorts your slice as long as we have order types within it, and it sorts it in ascending order. So just passing the slice in, we will get the sorted slice in place, and so it doesn't return any sort of slice. Let's go look at this over in code. So if I move this 5 all the way to the front, and then we call slices.sort on S1, which we can't actually do that. We have to just do it in place. So it's slices.sort S1, and then we can print out S1 here. We can save it, and then we'll see that we got 1, 2, 3, 4, 5 returned back to us within S1 already. All right, that's it for the video. Thank you for sticking around. This certainly isn't all of the functions within the slices package, but it's some of the ones that you might use the most. So if you stuck around to the end of the video, I highly suggest that you like it if you enjoyed or learned something, and I'll see you in the next one.